In stick nodes, the curve feature involves some math that may help you understand it more. The application of this lesson will affect your performance in animating as well, so that you can understand how curves work. With this simple figure, you can make some math problems to solve. But there's one rule to follow. The thickness of the segment must be an even number, since stick nodes does not support decimals. And also, some common questions. Will the length of the segment affect the curve? Only in the angle, not its height. And what should it look like when it's correct? It only touches one point of the line, being a tangent line. Now let's go with some examples. For the first example, we have this. If a segment has a thickness of 2 units, and the required height must be 18 units, how much curve should the segment have? With the assigned values, you can see what we have and what we're looking for with this diagram. For these problems, we will use this formula for finding the height of the curved segment, which is h equals c plus t over 2. Depending on what you're finding, you can manipulate the formula. H is the height, c is the curvature, and t is the thickness, which will always be an even number. Alright, so we're going to have to write the given. So we have h is equal to 18, c is equal to x, and t is equal to 2. Now let's just write the formula. H is equal to c plus parenthesis t divided by 2. Or you can write that one as t over 2, but that's your preference. Now we just replace them with their values. It's going to be 18 equal to x plus 2 over 2. And we have to transpose this to the other side so that the x can be alone. And when you transpose, it will change the sign. It will be 18. Let's just solve this. 2 divided by 2 is 1, obviously. Is equal to x. Or you can write it with x on the left side. And there will be no difference, but it's just better to look at. So 18 minus 1, we got x is equal to 17. And that's your final answer. Now, when you go back to the figure here, you can see the curve radius there is 0. Now if we put it with our answer, which is 17, you can see that it's tangent with the height, the black line, which means we got it correct. And if you got it correct, good job. Well, you solved it with me, so we're both correct. Now moving on. Now for the second example, if a segment has a curvature of 18 units, and the segment is 6 units thick, how much thickness should we add to the segment for it to reach the height of 33? Now let's write the given. So we have h, which is equal to 33, c is equal to 18, and t is equal to 6 plus x, because we're looking for how much we're adding to t to solve the problem. So as usual, we just put the formula c plus t over 2, which will become substituted with their values. 33 is equal to 18 plus 6 plus x over 2. So in this case, we will solve that. Since 6 can be divided by 2, we just write its answer, which will be 3. But x is a variable and cannot be divided by a number just yet. So it will remain as x divided by 2. Now we have to remove all of these clutter on x's side so that we can solve for it. And to do that, we have to transpose the 18 to the left side, transpose the 3, which so far will have 33 minus 18 minus 3. Don't forget to change the sign. Will be equal to x over 2. Now in this case, to remove the denominator of x, we have to multiply both sides by 2. But let's just solve for the left side first. So 33 minus, that's 18 minus 3. When you add them up, it will be negative 21. So that will be 12. It's equal to x over 2. And now we can just multiply both sides by 2. And by doing that, we eliminate the denominator on x's side. And now we're left with x is equal to 2 times 12. Now we just multiply, and we get x is equal to 24. Oh, come on, just write 4. There we go. That's the answer. Moving on to the next example. If a segment is 10 units thick and has a curvature of 16, what is the height of the segment? Now let's do the same thing. We have h, which is what we're looking for, which will be x, c is 16, and t is 10. Now as usual, we have the formula h is equal to c plus t over 2. Just replace the values. X is equal to 16 plus 10 over 2, which then will be 5. X is equal to 16 plus 5, and finally x is equal to 21, and that's our answer. The height of the line is 21. Easy math. Anyone can do it, even if you're not Asian. And for the last example, let us solve for the red lines problem. The blue line has a thickness of 16 units and a curvature of 33 units. And the red line has a thickness of 4 units and a curvature of 7 units. How much more curvature should be added to the red line to have the same height as the blue line? For this problem, you have to solve for the height of the blue line too. Now let's write the given, which is C1, T1, T2, and T2. C1 is the item we're looking for, which has the x, so it's 7 plus x. T1 is 4, T2 is 33, and T2 is 16. Now we have to solve for the height, which we can do with C2 and T2 because they have completed values. We cannot find it with C1, T1 because the variable is there, the x. So let's go solve for the height. H will be, let's just replace the values, 33 plus 16 over 2. And that'll be 8. So 33 plus 8. H is equal to 41. What am I thinking? Oh my god, that's an ugly H. Let's fix that real quick. There we go, beautiful. And now with H present, we can solve for the x. So H is equal to C1 plus T1 over 2. We'll just substitute the values in, and we will get 41 equal to 7 plus x plus 4 over 2. So this one will become 2. Then we can start transposing. 7 can go there, 2 can go there. Which then will leave us with x is equal to 41 minus 7 minus 2. And then the answer is x is equal to 32. Good job. We did it. Let's go. Now that we're done with the examples, these exercise items from earlier are for you to solve. The pictures are enough for you to solve, no need for a worded version. And when you're done, comment your answers down below and I will check it myself. Good luck and have fun. Alright, I have not told you how it helps you improve as an animator. Haha, it doesn't. You've been tricked into doing math.